Alright, so we have 2 pages left in this section before your next homework assignment. So we're going to finish this up. It's really dealing with the second derivative. And we're going to get to what's called the second derivative test. So we're going to go ahead and just jump right into it and get started. So I know it's been a while. As we go through it, over break, you'll start to remember some of the stuff that we had done before break, okay? So given the equation g prime of x, so the first derivative, determine the intervals where the graph of g of x is concave up and concave down, and determine the x values of the points of inflection. Show your analysis and give justification for your answers. So we're looking for concave up, we're looking for concave down, and we're looking for points of inflection. That's really what they want to know about in this problem, okay? They give us the first derivative. And just, it may help us out later in the problem. So I'm going to write this negative 12x. The bottom could be factored as what? It may help us later. That's why I just want to do it now. What could the bottom be factored as? X squared plus 3 squared. Yes. All right. So we may need that later. But now the first thing we need to actually do, we have the first derivative that's given to us. So we need to take the second derivative. How do I take the derivative of this?
Low d high minus high d low, and then you square the bottoms.
Yes. So the low d high, so x to the 4th plus 6x squared plus 9. Derivative of the top. Negative 12x changes to what? Negative 12 minus high, 12, negative 12x. Derivative of the bottom is what? 4x cubed plus 12x. And what do I do on the bottom? Okay, so I have x to the 4th plus 6x squared plus 9, and that's squared. Okay. Now I have a whole lot of terms on the top and a whole lot of terms on the bottom, so we're going to want to try to simplify this a little bit. All right. So after doing some simplifying and combining, you'd be left with negative 12 x to the 4th minus 72 x squared minus 108 plus 48 x cubed plus 144 x squared. Okay. On the bottom, how can I make this a little easier to read? What could I simplify that to? If I ignore the squares for a minute, do I know what the middle, does that simplify to anything? Yeah, what we found at the beginning. It will factor. So the factor was x squared plus 3 squared. But what if you square a square? You would get what as a power? 4. So x squared plus 3 to the 4th power now on the bottom. So the bottom looks a little more simple. What can I pull out of the top? Let's see. So if I simplify that a little more, actually I skipped a step. So I can simplify more. I would get what? X to the 4th. If I can combine my x to the 4th. 36. plus 72x squared minus 108. So that 48 should be x to the fourth, shouldn't it? Where I multiplied the negative 12x. It should be 48x to the fourth. Because when I multiply the negative 12x times the 4x cubed, that gives me x to the fourth there. That's where the 36 came from. Okay, so that's on the top. 36x to the fourth plus 72x squared minus 108. On the bottom, we still have x squared plus 3 to the fourth power. Okay, we can still simplify more. What can be pulled out of everything now? What's a common factor?
Indeed, top 36 is a common factor.
Exactly. I'm going to pull out 36. That will leave me with x to the fourth plus 2x squared minus 3. That looks a little nicer. Okay. Denominator still the same. Now, what would be really nice if the top does what? Yeah, if it factored. So let's see if we can get that to factor at all. We have 36. We want to try to factor something on the top. The bottom we're going to leave the same. So let's see if we can factor on the top. Give it a try. We're going to have some quantity with x squared times some quantity with x squared. Anybody figure out what the factors are? Daniel?
X squared plus 3 and x squared minus 1.
X squared plus 3, x squared minus 1. Very good. Okay. So that is that factored right there. Now what do we see? Now there's a lot of simplifying here, a lot of algebra on this problem. What happens now? This is going to cancel with one of those, so the new power on the bottom would be 3. Okay, so the one on the x squared plus 3 on the top, that completely canceled, and we got rid of one of the ones on the bottom. Okay. Leaves us with 36. The bottom is going to be x squared plus 3 to the third. Now, can I factor this further? X squared minus 1. Exactly. So I have 36 on the top, x plus 1, x minus 1. So all this simplifying, so much algebra, we're finally where we need to be now, okay? On the bottom, is there any numbers we need to worry about? Or are we okay with all real numbers? Can we plug any number into the bottom and we'll be okay? If we plug in 0, 0 plus 3, 3 cubed. So are we good with that? Is there any number that's going to give us a 0 on the bottom? No, because we have that squared value. So we're okay on the bottom, so there's nothing to worry about there. So if we think about this and we had this set equal to 0, the bottom doesn't matter. Our factors on top, though, what can we tell? What would be any critical points? Yeah, so if you set this equal to 0, if you multiply the denominator over, that's going to disappear, because this times 0 is 0. Then you just have the top left. Well, if you divide over 36, the 36 is going to disappear, and you just have your two factors. Now, if you solve those for 0, you get what? I think I heard it. Yeah, you get 1 and negative 1. So, x equals plus or minus 1. And since this is the second derivative, those are possible what? Possible, I know, think back. Go ahead.
Points of inflection.
Yeah, possible inflection points. So x equals plus or minus 1, those are possible inflection points. We don't know for sure yet that they are, but it's possible that those two values could represent inflection points. Now, I'm out of room, so I'm going to erase this top part, but I'll leave this down here since we just solved for that, because we're not quite done yet. So I'm going to erase this top part. Okay. So we found possible inflection points. Now it tells us we want to find concave up, concave down, and possible points of inflection and justify our answer. So we need intervals. So do you remember back to making the interval tables? Remember making tables for the intervals for first derivative and second derivative? What's the first interval we would be dealing with then for this example? From where to where? Exactly, negative infinity to negative 1, very good. The next one's going to start where? Exactly, very good. And next? Very good. Those are the three intervals we're dealing with, and those came from the possible inflection points we found down here. Plus or minus 1. That's why we're using the negative 1 and the positive 1 in our intervals. Okay. I'm going to create the table out of it. So we're talking about the second derivative here, f double prime of x. If we plug some value that's in this interval, within this interval, into the second derivative, so this was our second derivative down here, if you plug some number within this interval, do you get a positive or a negative answer? We don't care exactly what the answer is, but is your answer going to be positive or negative? So take a minute, plug a number within that interval in, and determine whether you get a positive or negative answer. Okay, you do get a positive answer. Okay. We're dealing with the second derivative. So if you get a positive answer, what does that tell you about the original? F of x would be concave up. So you can write concave up or draw the picture. I like to draw the picture, but that's concave up. Or if you want to do both, if you want to write concave up and draw the picture so you know what it looks like. So if the second derivative is positive, the original function f of x is concave up. Okay, very good. Let's do the same thing with the next interval. Pick a number within that interval. What's an easy number in that interval to pick? 0. So plug in 0, determine whether you get a negative or positive answer. Plug it into your second derivative. You get negative, very good. So f of x has to be concave down. And lastly, check the last interval. Pick a number within that interval, determine whether your answer is negative or positive. Positive. Concave up. All right, so before we write our conclusions, what can you tell me after this? After the concavity, what do we know now? Okay, what are points of inflection? Okay, so are both x equals positive and negative 1 both points of inflection? Yeah, so we knew that they were possibly points of inflection when we found them down here, but we did the second derivative test here. We used the table and determined that both of them were changes in concavity, so both were inflection points. So we can write a couple different conclusions here. We can say f of x is concave up, and on the intervals negative infinity to negative 1 and 1 to infinity. And your explanation for that, if they asked, it would be because the second derivative is positive within those intervals. So that's what you checked for. So f of x was concave up on those two intervals. F of x is concave down. F of x is concave down on the interval negative 1 to 1. Again, if they asked you why, well, it's because the second derivative was negative. And lastly, what we were really looking for, f of x has what? What does f of x have? Yeah, points of inflection at x equals negative 1 and x equals 1. Your explanation for that is because f double prime of x changes sign. So the biggest or the longest part of that problem was all the algebra and simplifying. As long as you can simplify the algebra part, get down to your possible points of inflection, then creating the table with your intervals really isn't too bad. But in that problem, all the algebra to get to that point took a little while. Okay? Any questions with that example? Okay? All right. Let's go down to the bottom of the page then. So while the second derivative is primarily used to determine intervals of concavity and points of inflection, just like we did above, we did both of those, it can also be used to identify relative max and mins of a function. All right, so this is the second derivative test, an alternate way to identify relative max and min using the second derivative. I guess this marker is not going to write. Try this one. If x is equal to a is a critical point. Of f of x. These are all junk. There we go. Then f prime of a equal to 0 or dne. So if x equals a is a critical point of f of x, then f prime of a is equal to 0 or does not exist. Making x equals a potential max or min of f of x. Okay, now we have three statements to make underneath this. So the first statement, if f double prime of a, we're going to say a here. If f double prime of a is positive, then f of x is what? What can you tell me? If you know that the second derivative of a value is positive, what does that tell you? The original is what? Concave up. So we know it's concave up at this point because we're talking specifically about a. So we know that f of x is concave up at x equals a. Which makes x equals a. So if we know at this point a, it's concave up, x equals a has to be a what? A max or a min?
Minimum.
A min. It's at the bottom because we know it's concave up. It's going up. So that point A is at the bottom. So x equals a is a minimum of f of x. Very good. All right. Second statement. If f double prime of a is negative, then f of x is what? If the second derivative is negative, the original concave down. At x equals a. Which makes x equals a what? Colton? Maximum, yeah. Maximum of f of x. Very good. So at that point, it's concave down at that point. So at that point, it's concave down. So that point A is a maximum. All right. 3. If f double prime of A is equal to 0, then x equals a is not a what? Close. What were we talking about up here? Yeah, it's not a max or min of f of x. So if it's equal to 0, it is not a max or a min. If it's positive, it's min. If it's negative, it's a max. Okay? So that's how we're going to use that second derivative test. Are we okay with that? We can go to the back? All right. So we have 2 examples on the back, and they fall right after that second derivative test, so we're probably going to be using that test we just learned. All right, so it says use the second derivative test to locate and classify all x values of relative extrema for the function. So they give us the original there. We should do what with it first if that's the original function? Okay, what comes before that though? Yeah, we have to do the first derivative. So we take the first derivative. Okay, and with the first derivative, what do we normally find? Starts with a C. Yeah, critical points, exactly. So we set that equal to 0, and we're going to try to factor it so we can solve for our x values. So we can factor out a 4x squared. That leaves you with x minus 3. So if you solve this for 0, or for x equal to 0, and this one for x when it's equal to 0, what do you get as your x values, your critical points? 0 and 3. So those are critical points. So again, before we go on, if you look back at that test, it's talking about those critical points. That A is that critical point. We just found 2 of them. Now we're going to plug those in to our second derivative, because it says if the second f double prime of A, well, you're plugging in those critical points to your second derivative now to determine whether it's positive, negative, or 0. So we have the critical points. Now we need the second derivative. So take the derivative of this again. 12x squared minus 24x. If you want to, you could simplify it. 12x, x minus 2, if you want to. But now we have to do what with that second derivative? We just mentioned it, but... Stevie? Yeah, plug in our critical points. So we'll start with f double prime of 0. 12 times 0, 0 minus 2. What do we get as an answer? 0 for that one. Okay. Let's check the other one. F double prime of 3. We get 12. 3 and 3 minus 2. Again, we don't really care what the physical answer is. We care if it's positive, negative, or 0. So our answer for this one, is it positive, negative, or 0? Okay. And a quick way to do this problem without actually calculating the whole answer, what's 3 minus 2? That's a positive answer. What's a positive times a positive times a positive? A positive. So you don't actually have to figure out what the final answer is. You know your answer is going to be positive, though. Okay? So now let's write our conclusion. Since f double prime of 0 equals 0, no min, I'm going to put slash max, you can put no min or max, no min or max at x equals 0. Since f double prime of 0 was equal to 0, there's no min or max at 0. Secondly, since f double prime of 3, well, we'll say is, we'll not put equals, is positive, f of x has a what? You guys tell me. If you have to flip back, that's fine. Yeah, if you look at your test, it's positive, so it has a min at x equals 3. And that's using the test. Okay? Not too bad? Alright, so we're going to make it a little more challenging. We're going to do the second example now with some trig functions. So try to remember your trig functions. Let's go on to the next example then. Any questions before we move on? We're okay? Alright, so next one. First step, we need to do what? Find the first derivative, and we're using that to find what? Well, critical points, yes. So we need to find the first derivative. So f prime of theta. Okay, f prime of theta. What is the derivative of 2 cosine theta? Think the 2 is a constant, so you can leave it out in front. So what's the derivative of cosine? Yeah, so negative 2 sine theta. Derivative of theta, think of it as an x. 1, so just minus 1. Okay. Set it equal to 0. Add 1 to the other side. Divide by -2. Now, critical points. Got to remember our trig functions. We should get theta equal to what? So if you think of the unit circle, just think about 1/2. If it was sine of what is 1/2? Pi over think of your unit circle. So if you think of just about 1/2, ignore the negative for right now. Sine of what is 1/2? Pi over, yes, pi over 6. But now we're talking about the negative 1/2. So negative 1/2, you're going to be on the bottom portion of your unit circle. You're going to have 2 spots, just past 180 and then almost the full circle. So if the original, if 1/2 was pi over 6, what are your other 2 values going to be? We know we're going to have something pi over 6 and something pi over 6. Exactly. Yes. 7 pi over 6 and 11 pi over 6. Those are your critical points. After I find critical points, now what do I do? Second derivative of theta. Again, the -2 can stay out in front. It's a constant. What's the derivative of sine? Good. And derivative of -1 or 1? 0 goes away. Okay. Now we have the second derivative. What do we actually do with the second derivative now? Plug in our critical points. Ooh. Okay. Now again, if you can think about what the answer is, you don't actually have to find the actual answer because we're looking for positive, negative, or 0. We're plugging in the 2 critical points, so this is just plugged in. You don't necessarily have to find the answer, you just have to determine whether it would be positive or negative. So if you think about this, the 7 pi over 6, if you're thinking about a unit circle, where is 7 pi over 6 going to be close to on this unit circle? It's going to be about where? Over here. Now above or below? Okay, it's going to be somewhere around this area. Okay? If we take the cosine of something that's in this area, do you get a positive or negative value here? Okay, you get a negative value. So the cosine of this is negative. What's a negative times a negative? So the answer for that one's going to be positive. Okay? Cosine of 11 pi over 6. Well, where is 11 pi over 6 going to be? It's going to be somewhere close to over here. So if I take the cosine of a value over here on the circle, is that positive or negative? Positive. So positive times a negative is a negative. Very good. So you don't necessarily have to know exactly what the answer is. You could use the circle to help you out. Now, if you would like to know, the 7 pi over 6, if you take just the cosine of that, you get negative square root of 3 over 2. And that one you would get square root of 3 over 2. All right, and we have two conclusions we can make out of this. What are they before we write them down? What are our conclusions from the second derivative test?
Since f double prime 7 pi over 6 is positive, is it
Exactly. Since the second derivative of 7 pi over 6 is positive, f of x has a min. Likewise, since f double prime of 11 pi over 6 is negative, f of x has a max. So remember those steps we followed again. If they're asking you to do the second derivative test to locate min and maxes, you take a first derivative, solve for your critical points. You find the second derivative and then just plug those critical points in and determine whether it's positive, negative, or 0. Okay? Any questions on those? All right, so if you're looking ahead in your notes, you do have a homework assignment after this. So you should start working on your homework. Make sure you're caught up with those. Work on the next homework assignment. Starting tomorrow, we're going to start the next section. And I would like to finish that section probably by Friday. And then that would set up for next week's, where I said the free response day is probably going to be Monday. And then the quiz on Tuesday. Okay. Any questions?